Hey, what's up, students? Hope you're having the best day of your life today. Today, I want to go through a short free response or a paragraph. This is going to include a pendulum. It gives you a graph. So this is the graph we're going to see. If you are on the AP College Board website under my AP, this question is called pendulum energy. So if you guys want to look that up, some students have been asking me, if I could give them the questions that I give my students. I get them all from the AP College Board website. So these are all public to you guys. Your teacher may have to unlock them. If they haven't, just ask them to unlock them. So essentially, there's going to be some givens here. We're going to have a mass of 0.2 kilograms, and it's going to be raised 15 degrees. This is the picture that we're given, and we're going to dive right into what they're asking us for. So after I read the question, if you want to pause the video and see if you can answer this question yourself, that'd be great. Then you come back and just see the solution here. The dot below represents the sphere at location 2. So location 2 is going to be right at the bottom. All right, so we had location 1, then we had location 2, and then we had location 3. That was given in the picture. All right, so they pretty much want to know what are the forces acting when it's at the lowest position here. They want you to draw a free body diagram with no components of force and the relative length of the vectors relative to the magnitudes of all forces. Now this relative length, that's very, very important. So what that means is a lot of times we'll use vectors and we'll use the length of those vectors to show their magnitude or relative magnitude. So if I showed these two vectors, I would say that this is 2 times the magnitude of this. So that's what they say when they mean relative lengths of the magnitudes of all the forces. So if whatever I draw, I know that on this ball, starting at the ball, we're going to have a line down here. And I'm just going to make this go 3 boxes, and that's going to be equal to weight, Fg. Okay? You cannot write mg, right? mg is not a force. Mg is how you find the force. So when you're doing free body diagrams, don't put in the formulas for them. Write the force. So if I used 3 boxes for the magnitude of Fg, I know that the force coming upwards is tension. But now what they're really saying is, do we understand the fact that the force of tension, which you can call F sub t, you can call it capital T, you can call it whatever you want, but what they want you to show is that you know that the force of tension is greater than the force due to gravity. So if you see, this is, and you wouldn't draw this part, I'm just showing you, this is 4 boxes, where this is only 3 boxes. And the reason that is because an object that is a pendulum, when an object is swinging like this is a circular path. So right here, although these are the 2 forces, Fg and Ft, and an object that's moving in a circle always has a net force acting on it, and that fancy word we call is centripetal force, right? Fc here is going to be equal to the force of tension minus Fg. So because there is a centripetal force, there is a net force. And if there is a net force, that means that Ft is not equal to Fg. Because if they were equal, then F net would be equal to 0 and there would be no centripetal force. So we have to show that Ft is greater in magnitude by giving it a longer length than Fg. So now it asks to calculate the maximum kinetic energy. And I know at a pendulum, when a pendulum swings, I'm just going to draw it up here from this part. At here, it's going to have some gravitational potential energy. And then as it swings, when it gets to the bottom, this is going to be maximum Ke. And all of that kinetic energy comes from the gravitational potential energy of when it dropped. So using the conservation of energy, I can say that the total energy initial is going to be equal to the total energy final. And I know energy is conserved because there's no outside forces acting. If I wanted to list all the energy before, I can say there's some potential energy before, there's possibly some kinetic energy before, and that's going to be equal to the potential energy after plus the kinetic energy after. But we know that it's dropped, it's starting from rest, so the Ke initial is going to go away, that's going to go to 0. And we also know that when it gets down to here, that delta H is going to decrease to 0. So with no delta H, this is going to be 0 as well. So essentially, I'm just left with Ug equals Ke. And this Ke is what they want to find, and I know to solve for gravitational potential energy, that's equal to mg delta H. So that's how I'm going to find the kinetic energy. But I get myself stuck here because I don't know the height that it's dropped. I only know that this theta was equal to 15 degrees. But if I can draw a little bit of a picture for you here and say when it was up here, it had some length of a string. When it was down here at the lowest position, it had that same length of a string. And this theta, they told us, was 15 degrees. Well, I can bring in some strategy here and say, if I go like this, and I call this the adjacent side and this the hypotenuse, adjacent and hypotenuse is going to be cosine. And then if I solve for this, then this distance right here, that's going to be delta y. So therefore, delta y is really this total length minus L cosine theta. Now, why is this L here? Well, because that's going to be the hypotenuse side. If that was a little bit tricky for you, I did cosine of theta equals adjacent over hypotenuse. So I call that this, it was A over L. So the adjacent side is really L cosine theta. That's how this happened right here. But now we get ourselves stuck again because I don't know what L is. So is there a way that I can find L? Well, it should have jumped out at you already that if you are going to be using a pendulum, they're probably going to ask you to use the period of a pendulum formula that's given on your reference table, which is 2 pi square root L over G. And guys, the period of the pendulum is given on the graph here, right? A period is one full cycle, which is going to be 2 seconds. So that's what I'm going to have to use for the period. But I want to solve for L. So the first thing I'm going to do is I'm going to try and isolate this rad because that's annoying. So I'm going to divide both sides by 2 pi. I'm going to get the period over 2 pi is going to be equal to the square root of L over G. Now, how do I get rid of the square root? That sucks. I'm going to square both sides, okay? Now, that's going to lead to the period of the pendulum squared over 4, got to square that too, pi squared, which is equal to now L over G. Now I can have an expression for L, which is going to be equal to G, the period squared, divided by 4 pi squared. Let's just plug in real quick. 10 meters per second squared times 2 seconds squared divided by 4 times pi squared. I find L to be equal to 1 meter. Now I can go back and I can play all the games and I can work my way backwards. So now I'm going to take this up to here and I'm going to say delta y is equal to 1 minus 1 times the cosine of 15 degrees. So my delta y is going to be equal to 0.034 meters. I'm then going to shoot this way over to here. And I'm going to say 0.2 times 10 meters per second squared times 0.034 equals KE. KE is going to be equal to 0.068 joules. A lot of work for this one, guys, but not that difficult. In this last part, they say now that it's raised to a new angle, so it's going to be less. So instead of 15 degrees, I'm going less than 15 degrees. The sphere is released from rest and the pendulum oscillates. Explain how the motion changes and give appropriate evidence. Okay, now guys, whenever you are writing paragraphs on this test, whether it's this type of question or anything else, you have to make sure that you address every single variable that could be affected in this problem. So whenever there's a paragraph, guys, what are the variables? You must ask yourself that. Now in this question, you're like, well, how do I know what the variables were? Well, go back and look at the problem we just did. We just worked with every single variable possible. For a pendulum, we use period, we use L, we use M, we use little g, we use delta y, we use gravitational potential energy, and we use kinetic energy. So when I'm going to explain this motion, I'm going to make sure that I address each one of these particular variables because that would mean that I fully explained everything I could when it comes to a pendulum. I would first start with this statement. The period of a pendulum is dependent on L and G as shown in the formula. The period of a pendulum is equal to 2 pi L over G. What this allows me to say is that since L and G are not changing, the period will remain the same. So now by making this statement right here, now we've crossed off a couple of variables that we've mentioned. We've mentioned this, and we've mentioned this. Next, I'll look at the variables I still have left. I still have mass, so let's say something about mass. I'll just say the mass will remain constant, so I'll have no effect on the motion. Then boom, that variable's gone for me. So now I just have to really talk about energies, which is really what's essentially happening here. By decreasing theta, you decrease delta y. This decreases UG because UG equals mg delta y. So now I've gotten rid of delta y and UG. So now I only have one more variable to talk about. Because the kinetic energy is dependent on the gravitational potential energy, it will also decrease, meaning the maximum speed of the ball will decrease. We could actually say we even talked about speed here. This right here is a perfect answer. And like I said, all I did was list my variables, and then I made sure that I talked about them. I used some formulas, and I just gave some relationships of potential energy to kinetic energy. This right here shows awesome knowledge of physics. If you guys have any other questions about this problem or any problem in particular, leave them down in the comments below. I hope you have yourself an amazing day.